All right, welcome to the lesson video for Unit 7, Day 4, our final lesson of Unit 7. Today we're going to be talking about specific proportions in triangles. Now, we've talked about proportions between similar triangles before, and so this warm-up you see here at the beginning of your notes page is actually a review of using proportions between similar triangles to find missing measurements. So if you want to pause the video here, take a few minutes to try and do these two warm-up problems. If you get stuck, you're welcome to click play and watch the solution being worked out so that you can just review the previous lessons. Okay, if you need more time, go ahead and pause again here. Otherwise, these are the answers we should get. So we see how we can use proportions to solve for a missing side of a triangle, but again, the established idea is that these polygons are similar to start with. Well, now we're going to look at proportions within a single triangle. So there's a lot of different angle and segment relationships that create proportional relationships within triangles. So we're going to look at that. So for starters, we do know if two triangles are similar, then the following corresponding parts are also proportional between these triangles, proportional to the corresponding sides. So the ratio of the altitudes, BD and FH, would equal the ratio of corresponding sides. So AB corresponds to EF. I could also say it's the same as the ratio as BC to FG. Okay, that's an individual side ratio. It's going to be the same as the ratio of altitudes. Okay, we have angle bisectors here as well. So these would be examples of angle bisectors. Okay, QS is an angle bisector, UW is an angle bisector. Those two segments would also be proportional. Okay, QS to UW would be the same as the ratio of QP to UT, or the same as the ratio of QR to UV. Again, just other ways we can set up these proportions. And then if we also had medians within a triangle, this would be an example of a median. Remember, a median connects an opposite vertex to the midpoint of an opposite side. Those would also be proportional to the side ratios. So the ratio of HJ to LN would be the same as GH to LK. That would be the same ratio as another set of sides. And I left both these blank, so we'll just pick one. Let's say HI to LM. Okay, so we have these proportions and these ratios we can use with similar triangles in addition to their side measurements. So here's what we have. Okay, we have similar triangles. GHI is similar to MLK, and we've drawn an altitude for both triangles. This is an altitude of 10. The other triangle has an altitude of 8. So again, we're going to set up a proportion using those. So the ratio of those altitudes, let's say I'm going in this direction, from bigger triangle, GHI, to smaller triangle, MLK, that ratio of 10 to the other altitude of 8 has got to be equal to the ratio of sides. Well, X is the side given here, and X is the length of HI, which corresponds to LK, which is my 14. So again, we just set up a proportion again. 10 times 14 is 140. 8 times X is 8X. All we have to do is divide by the 8. 140 divided by 8 is 17.5. Okay, so the length of X would have to be 17.5. Okay, we can try the same thing given this situation. Instead of altitudes this time we are given angle bisectors, but it doesn't really change how you do the problem. It's still a proportional relationship in these similar triangles. So again, if I did the altitude ratio of 32 over 24, that would be the same as 38 over X. So again, we just cross multiply. 32 times X is 32X. 24 times 38 is 912. So I'm going to divide both sides by the 32 here. and we get this x is about 28.5. Okay? So we can continue setting up those proportions. Once again, we have another scenario here. This time we're dealing with a median, and medians would also be proportional. So the ratio of the first median, 20, to the second median, 12, would have to be the same as the ratio of these two corresponding sides. 2x minus 9 over x minus 2. So what I want you to do here, I want you to try and take some time and solve this proportion on your own. Pause the video if you need some more time. All right, now that you've had some time to work this out, hopefully this is the answer that you get. Okay, we should get x is 26. All right, that is all fairly similar to the work that we've already been doing with similar triangles. However, now we're going to take a look at proportion relationships within a single individual triangle. Okay, and the first one we're going to look at is this theorem called the triangle angle bisector theorem. And here's what it states. An angle bisector in a triangle separates the opposite sides, or opposite side, into two segments that are proportional to the lengths of the other two sides. So this angle bisector, we'll zoom in on my picture. This angle bisector splits this opposite side, UW, into two segments, UX and XW, that are proportional, not equal, but proportional to their matching other sides. So what that tells you is the length of UX in ratio to the length of WX would be the same as this side of the triangle UV compared to the other side of the triangle WV. Okay? So we can see that worked out in these examples. So what we have is that we have an angle bisector for each one of these pictures. So this is our angle bisector. That means that this segment compared to the other segment X has got to be equal to this side 12 compared to the other side 18. So we can set up that proportion. 4.8 over X has to equal 12 over 18. And again, we have a proportion. We just cross multiply to solve. 4.8 times 18 is 86.4. That has to equal 12 times x. Now we just divide by the 12. And we get x is about 7.2. Okay? Once again, we can set up the same kind of problem over here. This segment, because KM is an angle bisector, and this segment are proportional to these two sides of your triangle. Now, before we jump into this, there is something you need to pay attention to. They tell you that JL is 39. That means to find LM, I have to do 39 minus the 15. 39 minus 15 is 24. So that's the number I'm going to use in my proportion. So that proportion should look like this. 15 to 24 is equal to x over 36. Okay? So if I cross multiply again, let's do 15 times 36. That's 540. That has to equal the same as 24 times x. So we just divide by the 24. And we get x is about 22.5. You'll notice in this lesson we are getting some more decimal answers, but most of them are exact decimals, so it's not too much of a challenge. Okay, we've got one more of these I want to try, and we're going to set it up, and then if you want to go ahead and solve it, you can, but we'll kind of speed through how to get to the answer. Once again, we have an angle bisector. Okay, that creates 27 here. This other segment from M to L, again, we find by doing 45 minus 27, which is 18. So I can compare that to these two sides of the triangle. So once again, 27 over the 18 we just found has got to be equal to 3x minus 9 over the x plus 11. Okay, these are proportions we've done before. If you want to pause the video to try this one yourself, you can. Otherwise, this is the answer we should get, and you'll see the work to get that. Okay? So moving on to the next section here, we have another theorem we're going to look at that, and that is called the triangle proportionality theorem. In the triangle proportionality theorem, it just says if a line is parallel to one side of a triangle, and it intersects the other two sides, then it divides the sides into segments of proportional lengths. So once again, these lines are parallel. Okay, we have the parallel lines here. What it does is it splits these opposite sides into proportional segments. So if I know that DE is parallel to AC, that means I have a ratio of proportion. That means the ratio of DB to DA is got to be equal to the ratio of EB to EC. So we can try that with some examples. These are almost even easier to set up than any other proportion we've dealt with. Okay, so once again, we've got two parallel lines. That means I've got proportional segments. So I'm not dealing with similar triangles here. They would be similar, but I don't have to add the individual segments to get the total triangle length like we did in the day 3 lesson or day 2 lesson. Now we can just compare the individual segments. So we can say 14 over 12 has to equal x over 15. And cross multiply there. If I do 14 times 15, that's 210. That has to equal 12x, and just divide by 12. And x gives us 17.5. Okay? Now, on part B, before I move too far along, to find this segment, remember, we've got to do some subtraction because the whole thing is 27. So if I do 27 minus 6, I get 21. So I can actually set up this proportion. 21 over 6 is equal to x over 7. 7, let's try that. 7. So again, we can cross multiply. 21 times 7 is 147. That equals 6 times x, or 6x. Divide by your 6. And we get x is 24.5. Okay. If you would like to try the next one on your own, you can try and set that up. I will show you what the answer is here in a moment. So pause the video here and try and work out part C on your own. Otherwise, this is what we should get. Okay? Very good. Now, this same fact about parallel lines in a triangle carries over to just proportions created by parallel lines in general. Basically, it's like we're taking a triangle and we're just looking at this bottom part where I have multiple parallel lines. Because of these parallel lines would create proportional segments in a triangle, it also creates parallel or proportional segments here to here would be the same ratio as here to there. So I can set up that statement like this. If AB is parallel to CD, and those are also parallel to EF, then I get these segments in relationship. AC compared to CE has to be equal to BD compared to DF. Okay? Another way we could say this, if, like, say I called that X, that Y, that Z, and that W, I could just as easily say X over Z equals Y over W. Okay? So we can use that to set up and solve proportions this way. All right? For example 4a, it should look like this. 45 over 18 has to equal 52 over x. Again, cross multiply. 45x equals 18 times 52 is 936. Divide by your 45, and x is about 20.8. Same idea here. 24 over 3x plus 1, or rather, let's back that up. 24 over 18 equals 3x plus 1 over 12. Okay, once again we cross multiply. Remember, when you do 3x plus 1 times the 18, you have to distribute to both of these. So the 24 times 12 is 288. And then if I do 18 times the 3x, I get 54x. And then 18 times 1 is just 18. So I'll subtract the 18 from both sides here, creating 270 equals 54x. Then just divide by your 54. And that gives us x is 5. Okay, that brings us to the end of our lesson video. You should be prepared now to work on the assignment for Unit 7, Day 4.